Okay, this case is of a 37-year-old white male. He is 69 inches tall and weighs 275 pounds. So his BMI is 40.6. He's referred to the pulmonary function lab after an evaluation in the sleep laboratory revealed obstructive sleep apnea. He admits to daytime somnolence. His baseline pulmonary function studies are revealed below. So we have 3 different things to look at here. First, here is our PFTs. Here's our blood gases. And then this over here is they actually did a ventilatory drive test by having him rebreathe CO2. So we're going to get to that here in a minute. But first, let's look at our spirometry and figure out what this means. So the first thing we're going to do is calculate out our FEV1 FVC ratio. So it'll be 2.7 divided by 3.2, and what we get is 84%. So remember, if you remember back to this, that's on the normal to high level. So the next thing we're going to look at is our FVC. So our FVC is 72% up predicted. Okay. Go back to our picture here. If it's low, then we're going to assess our TLC. So let's take a look at our TLC here. Our TLC is 71% of predicted. Again, that's less than 80%, so again, that's low. So what that tells us is we have a restrictive defect. The next thing I wanted to look at, though, is we do have this RV-TLC ratio available, and it's 22%. That's actually in the normal range. What's important about this is to remember that his TLC is low, though. So although this looks normal, he actually does have a restrictive disease process going on because his TLC is actually reduced, as is his FVC. Okay, now let's take a look at our blood gases. What's going on here? What information can we gather? His pH is 7.36, that's normal. CO2 is 47, that's normal. PO2 is 77, that's little on the mild hypoxia side. Bicarb is 28, that's on the high side of normal. And then our SaO2 is 93%. Okay, next we're going to be looking at our ventilatory drive test. The recording technologist states that all data obtained during the CO2 rebreathing test were acceptable. The PETCO increased appropriately and the test was terminated after 4 minutes of rebreathing. The P100 was obtained at baseline, that's the occlusion pressure, after 2 minutes and near the end of the test. All pressures were repeatable and the average values were reported. So the question we have for ourselves after knowing what the tech said and having the data available to us is, does this patient have a normal ventilatory response and a normal ventilatory drive? Now, to figure that out, the normal ventilatory response is looking at our exhaled CO2 and our minute ventilation. So if you're a nice healthy individual and you are forced to rebreathe CO2, that means CO2 is going to start to build up and your body's going to start to breathe faster to try and blow that CO2 off because your body doesn't want an elevated CO2. So you should see the minute ventilation increase. Okay, that tells you about your ventilatory response. Next, your ventilatory drive, that's how strong you're going to suck in or pull that air into your lungs every time you breathe, and that's measured with your P100, your occlusion pressure. So let's take a look at some of our calculations here. So again, our blood gas is pretty much normal. Our expiratory flow rates are normal, but we know that there's a restrictive defect based on our FVC and our lung volumes. Okay, so to calculate our ventilatory response, we're going to measure or calculate, I guess, our change in PETCO, that's our exhaled CO2. So to do that, we take the final measured exhaled CO2, which is 59, okay, and subtract out the very first initial measured exhaled CO2, which was 43. So the difference in exhaled CO2 during the test was 16 millimeters of mercury. Okay. Next, we need the change in minute ventilation. So we start with the final minute ventilation recording, which is 17.1. You subtract out the initial minute ventilation recording, which was 4.5. Okay. And divide that by the change in exhaled CO2, excuse me, took me a minute there. So you get a difference of 12.6 in your minute ventilation. You divide that answer, by your exhaled CO2, and what you should come up with is 0.8 liters per minute per mmHg. Okay, so a normal ventilatory response is going to be that the person increases their liters per minute per mmHg by at least 1. Actually, the normal range is like 1 to 6. So this patient didn't even get 1. He's at 0.8. So he does have a diminished ventilatory response. As he rebreathes CO2, he doesn't start to breathe as fast as he should to blow off the CO2. That's what that's saying, okay? Next, let's take a look at the drive. And to do that, we look at the occlusion pressure. So the change in occlusion pressure from the end of the test to the beginning of the test. So at the end, it was 12, and at the beginning, it was 2.2 centimeters of water pressure. So subtract the 2.2 from the 12, and you end up with 9.8. Okay, you divide that by your change in exhaled CO2, which is 16. Okay, we got that from here. So 9.8 divided by 16, and we end up with 0.6 centimeters per water pressure per mmHg. So the normal occlusion pressure would have a P100 increase by at least 0.5 centimeters of H2O change in Petco, and so he's got 0.6. So he actually does have a normal ventilatory drive. He just has a blunted ventilatory response. He sucks in hard enough, he's just not breathing fast enough to blow off the CO2. Alrighty.